Greetings everyone, welcome to Catalysis by Vedantu. My name is Pahul, and today with me you are going to study the third class of the chapter Basic Concepts of Chemistry. In the first class we have already studied fundamental quantities, fundamental units. We've understood significant figures, scientific notation, laws of chemical combination. In the second class we've understood the mole concept, and now today is the time for one of my favorite topics, stoichiometry. Stoichiometry basically comes from two words. Stoichio means element and metry means measurement. So measurement of elements essentially. This is the pronunciation, stoichiometry. Phonetic, this is called phonetics. Stoichiometry is the relationship between the quantities of reactants and products before, during and after the chemical reactions, following chemical reactions or after chemical reactions. So we can have different types of chemical reactions. Simple one, alcohol getting burned in excess of air, a complicated redox reaction. So basically, what is the relationship between the quantities of reactants and products is stoichiometry. Now the good thing is that a few days back, Pulkit Sir and I made a really nice video explaining all about stoichiometry using sandwiches. Okay, so sandwiches can explain stoichiometry very well. So I will put that video over here now, watch it, and once you're done watching it, we will solve a lot of questions.
अरे पुलकित सर ये क्या कर रहे हो? ये क्या कर दिया सर आपने? ये x y z से ये केमिस्ट्री का सवाल क्यों सॉल्व कर क्यों रहे हो ये?
यार एक बच्चे ने मुझसे केमिस्ट्री का क्वेश्चन पूछ लिया, तो व्हाट आई एम थिंकिंग इज कि एक इक्वेशन है, कुछ वेरिएबल्स हैं, कुछ कंडीशंस गिवन है, we'll solve it, right? That's what we do in maths. नहीं
सर ये अलजेब्रा का सवाल नहीं है, स्टोइकियोमेट्री का सवाल है, ऐसे नहीं होगा सॉल्व ये।
तो मतलब तो कैसे होगा फिर?
बताता हूँ मैं, ऐसा करते हैं, तो सैंडविच खिलाता हूँ फिर समझाता हूँ, आ जाओ।
चल सैंडविच खाते हैं।
सर ये खाओ।
क्या ये?
खाओ ना, इससे ये खा के आपको स्टोइकियोमेट्री समझ आ जाएगी।
क्या ये सैंडविच?
हाँ, ब्रेड चीज सैंडविच खाओ।
ब्रेड चीज सैंडविच, बस दैट्स इट, कुछ नहीं है इसके अंदर और। समझ आ जाएगी, खा लेता हूँ फिर।
जादू है जादू।
वाह, सैंडविच तो खा लिया, अब बता।
आगे समझ।
क्या?
स्टोइकियोमेट्री
है?
समझ नहीं आया?
स्टोइकियोमेट्री? नहीं मतलब सैंडविच क्या बोल रहा है यार पाहुल?
Wait, let me show what I mean.
ये क्या क्या लेके घूमता है भाई तू अपने बैग में?
थोड़े से नंबर से खेलते हैं। I'll give you some bread, I'll give you some cheese. आप मुझे ये बताना कि इससे कितने सैंडविच बन सकते हैं, ठीक है? सिंपल है। ये मैंने दे दिया आपको 8, ठीक है?
6, 7, 8 भाई।
8 ब्रेड दे दिया आपको मैंने।
8 ब्रेड पीसेस, सही है।
बढ़िया। अब मैं आपको दे देता हूँ चीज़, थोड़ा कम दूंगा, ठीक है? लो 8 ब्रेड दे दी, पर चीज़ सिर्फ 6 ही दिया आपको मैंने।
6, 1, 2, 3, 4, 5, 6, ठीक है।
अब इससे कितने सैंडविच बनेंगे?
2 पीसेस से एक सैंडविच बनता है, राइट? सो 2 से 1 4 सैंडविच बनेंगे। 8 ब्रेड।
चीज़ डालो तो सही, चीज़ के बिना क्या मजा आएगा,
है ना? और अपन इसमें 4 चीज़ भी डाल देंगे तो 1, 2, 3 एंड 4।
आप बिल्कुल सही कह रहे हो, बट आपने ध्यान दिया कि हमने ब्रेड ज़्यादा ली थी, चीज़ कम लिए थे, पर यहाँ तो चीज़ बच गए ना।
हाँ बट ऑब्वियस नहीं है, तेरी 2 ब्रेड से एक सैंडविच बनता है, राइट?
सर सोच के देखो, डजंट दिस फील लाइक अ केमिकल इक्वेशन?
यस।
2 breads plus 1 cheese gives me 1 sandwich, है ना? एकदम
Perfect, yes.
केमिकल इक्वेशन जैसा। और इसमें शुरू में लग रहा था कि ब्रेड ज़्यादा है, चीज़ कम है, बट बिकॉज ऑफ द रेशियोज इन विच दे वर कंबाइनिंग, ब्रेड पहले खत्म हो गई और चीज़ बच गया। सिंस ब्रेड गॉट फिनिश्ड फर्स्ट, it limited my entire process.
Yes.
We'll call bread the limiting reagent.
सही है, of course। और
अब ये जो बच गया,
2 remaining.
So we can call cheese the excess reagent.
Excess reagent.
ठीक है। अब सर इस केस में परफेक्ट सिनेरियो क्या होता? What would have been the perfect scenario?
अगर इन दोनों को मैं फ्रिज में रख देता, होते ही नहीं है, गायब। परफेक्ट सिनेरियो।
Absolutely.
तो कितना हो गया? 8 ब्रेड पीसेस एंड 4
Slices of cheese.
slices of cheese.
Right? तो ये तो समझ आ गया अपने को।
Yes.
अब ये कर लिया ना आपने, आपका वो अमोनिया वाला सवाल ऐसे सॉल्व हो जाएगा। चलो करके दिखाता हूँ। तो सर अब ये जो सवाल है, इसको मैं आपको ब्रेड और सैंडविच के हिसाब से समझाता हूँ आराम से, फिर आप ये खुद सॉल्व करना।
ठीक है।
सो व्हाट वी लर्न फ्रॉम दैट ब्रेड चीज एग्जांपल इज दैट व्हेन थिंग्स आर इजी टू इमेजिन बड़े आराम से स्टोइकियोमेट्री सॉल्व हो जाती है। तो ब्रेड चीज का ही केमिकल इक्वेशन बना के उससे हम थोड़े से रिजल्ट्स निकालते हैं, थोड़े से पैटर्न्स ऑब्जर्व करते हैं, एंड वही पैटर्न्स यूज करके वी विल सॉल्व दैट अमोनिया क्वेश्चन वंस अगेन। ऑलराइट, अब अपने पास सबसे पहले कितने अमाउंट्स लिया थे अपन ने वो लिखेंगे अपन। ऑलराइट, सो ये जो मैं तरीका बता रहा हूं ना, कोई भी स्टोइकियोमेट्री का सवाल हम इसी मेथड से सॉल्व कर सकते हैं, तो इसको ध्यान से देखना और लिख भी लेना नोटबुक में। अपने पास कितनी ब्रेड स्लाइस थी? 8 slices ऑफ ब्रेड, देयर वर 6 slices ऑफ चीज। अब इसे कितने सैंडविच बन सकते हैं? ऑब्वियसली 4, बिकॉज ब्रेड खत्म हो जा रही है 4 सैंडविच के बाद, राइट? दिस इज द वन दैट स्टॉपिंग द रिएक्शन बिकॉज ऑफ द रेशियोज इन विच दीज थिंग्स आर कंबाइनिंग। Stoichiometry means the study of ratios, all right? And these numbers that we've marked over here, 2, 1 and 1, जिससे आप chemical equation को balance करते हो, these are known as stoichiometric coefficients, all right? अब यहाँ पे easy है imagine करना that this is the limiting reagent, but in the case of complicated chemical equations like the one we saw earlier, ये imagine करना इतना आसान नहीं है। तो कुछ चीजें करते हैं, उससे बहुत इजी हो जाएगा समझना हाउ टू फिगर आउट व्हाट्स द लिमिटिंग रिएजेंट। ठीक है, यहां पे अपन एक नई क्वांटिटी लिखते हैं, रेशो। अब इसको आपने जो बोलना है बोल लो, आर बोलना है, एक्स बोलना है, वाई बोलना है, व्हाटएवर यू वांट टू कॉल इट, लेट्स कॉल इट आर फॉर द सेक ऑफ सिंप्लिसिटी। ये रेशो क्या है? दिस इज द रेशो ऑफ द इनिशियल अमाउंट टेकन डिवाइडेड बाय द स्टोइकियोमेट्रिक कोएफिशिएंट। ओके, यहां मैं लिख देता हूं, दिस इज द इनिशियल अमाउंट टेकन डिवाइडेड बाय स्टोइकियोमेट्रिक कोएफिशिएंट। ठीक है, ये अपनी क्वांटिटी है। ब्रेड के लिए कितनी आ जाएगी? ब्रेड के लिए दिस विल बी 8 डिवाइडेड बाय 2, दैट इज 4। चीज के लिए कितनी आ गई है? 6 डिवाइडेड बाय 1, दैट इज 6। 4 और 6 में से छोटा नंबर कौन सा है? विच वन इज द स्मॉलर नंबर ओवर हियर? ऑब्वियसली 4। This is smaller. The smaller number will become the limiting reagent. As simple as that. Now what we have to do is we need to figure out a perfect scenario. In the perfect scenario, what we have to do is we need to take the excess reagent. जितना भी excess है ना वो फ्रिज में रख देना चुपचाप उठा के. That's all we need to do. So in the perfect scenario, bread will remain the same because that is the limiting reagent. उसको उतना ही लेना है. 8 pieces of bread. चीज कितना लगेगा यहाँ पे? 4 सैंडविच बनेंगे, 4 पीस चीज लगेगा, 2 चीज अपन वापस फ्रिज में रख देंगे. So in the perfect scenario, we have only 4 slices of cheese, right? इससे बनेंगे 4 सैंडविच. Now over here there is a very interesting observation that I want you to write down. Observation ये है कि in the perfect scenario, if I take the ratio R 8/2, 4/1, 4/1. Do you realize that all these numbers are equal to each other? Yes. Please write this down in your notebooks that in the perfect scenario, our ratios are equal. अब आप बोलोगे सर ये क्यों बता रहे हो? ये तो बड़ा obvious है, ये तो दिख रहा है. यहां दिख रहा है, बट जब हम अमोनिया वाला सवाल करेंगे ना, इतनी आसानी से दिखेगा नहीं. एंड वील यूज दिस ऑब्जर्वेशन टू सॉल्व दैट क्वेश्चन. ठीक है, अब पुलकित सर आएंगे और वो जो सवाल था ना वो मेरे साथ सॉल्व करेंगे. देन वील सी हाउ टू अप्लाई ऑल ऑफ दिस इंफॉर्मेशन ऑन टू दैट क्वेश्चन.
लेट्स बैलेंस द केमिकल इक्वेशन.
यस,
राइट, ही करते हैं ना. सो 2n2, तो यहाँ पे भी 2 एंड 6, तो यहाँ पे हो जाएगा 3. राइट, एम आई करेक्ट? उसके बाद तूने क्या किया था? इनिशियल अमाउंट लिखे थे, राइट? सो लेट्स राइट डाउन द इनिशियल अमाउंट्स. इनिशियल अमाउंट अपने को दिया हुआ है 50 एंड वहां पे दिया हुआ था अपने को 10, और फिर तूने निकाला था रेशियो, करेक्ट? सो लेट्स फाइंड आउट द रेशियो. तो रेशियो क्या हो गया था? अमाउंट अपॉन जो यहाँ पे n2 का कोएफिशिएंट है, करेक्ट? 50/1.
एक सेकेंड, आपने एक जगह गलती की है, बताओ कहाँ की है? ये क्या दिया है?
अच्छा, ग्राम. ओ,
यहाँ पे अपने को क्वांटिटीज लेनी है, ग्राम नहीं लेने.
विच आर मोल्स, राइट?
नंबर ऑफ एटम्स लेने हैं यहाँ पे.
नंबर ऑफ एटम्स लेने हैं, करेक्ट. सो नंबर ऑफ एटम्स अपने होते थे 50, करेक्ट मी 50 डिवाइडेड बाय नाइट्रोजन का जो मॉलिक्यूलर मास है.
Yes, given weight divided by molecular weight is equal to number of moles of the substance. Number of moles is an expression of the number of molecules that are there. ठीक है?
Got it.
तो moles कैसे निकालेंगे? 50 divided by N2 का molecular weight आएगा
28
grams
yes.
per mole.
28 grams per mole. So
Yes.
50 upon 28 moles हो गए नाइट्रोजन के.
Exactly.
Similarly 10 upon
हाइड्रोजन का वेट होता है 1 for atom, 2 for molecule.
2. Yes. So 2 हो जाएगा.
Yes.
Correct. So 10 by 2 moles of hydrogen is what we have. Perfect.
Absolutely. अब रेशो निकालो.
So we have 50 upon 28 divided by हम लेंगे 1. करेक्ट. तो चलो डिवाइडेड बाय हम ले लेंगे 1 और अपने पास यहाँ पे है 10 by 2 विच इज 5. कैन आई राइट 5 डायरेक्टली?
Yes.
ठीक है. 5 डिवाइडेड बाय अपने पास हो जाएगा यहाँ पे 3.
Absolutely.
परफेक्ट. सो वी हैव दीज रेशियोज.
Now to figure out इन दोनों में से limiting reagent कौन सा है, which number out of these two is smaller?
तो ये है 5 by 3 और ये है 50 by 28. सो दिस कैन बी रिटन एज 50 by 30.
Absolutely.
50 by 30, 50 by 28. तो यार यही बड़ा होगा ना, जिसका डिनोमिनेटर छोटा वो नंबर बड़ा. भाई ये तो मैथ्स में आता है अपने को. सो दिस इज अ बिगर नंबर.
This is the smaller number.
तो दिस इज द लिमिटिंग रिएजेंट.
Absolutely.
परफेक्ट. तो ये अपना हो गया है लिमिटिंग.
यहाँ पे एक बार लिख देंगे.
लिख दूं यहाँ पे
This is the
limiting?
limiting.
परफेक्ट.
इतना हो गया. Now we know that this guy is going to decide our perfect scenario. चलो सर अब perfect scenario बनाओ.
लेट मी राइट इट एज परफेक्ट. एंड परफेक्ट में हम क्या करते हैं, लिमिटिंग रिएजेंट जो होता है उसका जो अमाउंट है वो तो पूरा पूरा कंज्यूम हो ही जाएगा. सो लेट्स राइट इट. सो दैट इज 10 by 2 विच इज 5. सो 5 तो कंज्यूम हो ही जाएगा.
Absolutely.
ठीक है. अब ये 5 नाइट्रोजन कितने खाने वाला है, ये ब्रेड चीज कितने खाने वाला है ना? ये
Yes.
करना है अपने को. तो क्या लूं उसको, एक्स ले लूं? नहीं, एक्स ले लेता हूँ.
X कर लेते हैं.
लेट्स टेक इट
So
एक्स.
the thing is कि यहाँ पे कैलकुलेशन थोड़ी डिफिकल्ट है ना. चीज ब्रेड तो सिंपल था, वहां तो एकदम से पता लग गया था. बट यहाँ पे क्योंकि कैलकुलेशन डिफिकल्ट है, परफेक्ट सिनेरियो में हाउ मच नाइट्रोजन विल बी कंज्यूम्ड उसको x लिख देते हैं. तो लिमिटिंग रिएजेंट वैसे ही लिख दिया और जो एक्सेस रिएजेंट है उसको लिखा x.
और जो रिजल्ट बन रहा है अपना उसको z ले लेते हैं. फिर ले लूं z?
Yep.
ठीक है. कूल है.
Right. So this is the perfect amount that will be consumed for nitrogen. Perfect amount for hydrogen is the same as the initial amount because it's limiting reagent. कितना प्रोड्यूस होगा उसको अपन ने z ले लिया. Now sir, what was the last result that I told you about in the bread cheese case?
Oh, the ratios. तो इसको लिखता हूँ फिर मैं x upon नाइट्रोजन का जो कोफिशिएंट है which is 1. So x upon 1 must be equal to 5 upon जो हाइड्रोजन का कोफिशिएंट है which is 3 and must be equal to जो अमोनिया है उसका कोफिशिएंट which is 2 in this case. Yes.
हो गया सवाल सॉल्व.
अरे
Now
क्वेश्चन सॉल्व.
all you need to do is calculate x which is 5 by 3, z which is 10 by 3.
10 by 3.
So moles of nitrogen consumed will be equal to 5 by 3 moles. Moles of NH3 produced will be equal to 10 by 3 moles.
Yes. So लिखते हैं अपन. क्वेश्चन में पूछा था अपने को moles of ammonia produced. ठीक है ना? तो वो कितना हो गया? Which is equal to 10 by z is equal to 10 by 3 from here, right?
Yep.
Correct. So this gives me 10 by 3. But ये तो moles है ना? Oh, ये तो
सवाल जो है वो शुरू में weight में दिया था. If the question is given in weights and they ask you what is the amount of something formed, you have to give the answer in the weight itself. क्योंकि क्या होगा ना, जेई वाले थोड़े समझदार होते हैं, नीट वाले समझदार होते हैं. वो क्या करेंगे, ये भी ऑप्शन में दे देंगे, 10 by 3 भी ऑप्शन में दे देंगे आपको. आप 10 by 3 मार्क करके आ जाओगे, वो गलत हो जाएगा क्योंकि उन्होंने वेट में पूछा हुआ है.
Yes.
तो इसका वेट कैसे कैलकुलेट करेंगे?
तो moles multiplied by इसका molecular weight.
Absolutely.
Awesome. So 10 by 3 multiplied by कितना होता है अमोनिया का?
14 plus 3.
14 plus 3. Yes. तो हो गया 17. बहुत बढ़िया. Into 17 grams. तो ये आंसर है?
Yes.
बहुत बढ़िया.
सर मैथ वाले उसको सॉल्व तो करो.
अरे 170 by 3 तो लिख देते हैं. 170 by 3 grams is 5.66 grams, right? तो बच्चों इतनी अमोनिया प्रोड्यूस हो जाएगी.
Now I have a question for you guys. आपने क्या करना है? X निकालना है, ठीक है? And then you have to tell me what is the amount of nitrogen that is left behind in this reaction. जो excess reagent अपन ने फ्रिज में रखा था ना चीज का, यहां बताओ कितना नाइट्रोजन अपन वापस फ्रिज में रखेंगे in grams. वो जो है, that is something you have to tell me in the comment section down below. So people, the thing now is कि stoichiometry में यही है बस. No matter what question is presented to you, it can be solved using this template. But ऐसा मत सोचना कि मैंने solve करके बता दिया, सर ने solve करके बता दी तो आपको सारी stoichiometry आ गई. You have to practice stoichiometry on your own. And to make that task simpler for you, description box में जाओ और वहां पे हमने एक ट्यूटोरियल का लिंक आपको दिया हुआ है. उसमें अच्छे से थोड़े बेसिक से लेके थोड़े एडवांस लेवल तक स्टोइकियोमेट्री के क्वेश्चंस हैं, उसको सॉल्व करो और उसमें कोई दिक्कत अगर आएगी तो मुझे कमेंट्स में बताओ. सो पीपल, इफ यू एंजॉयड दिस, यू नो व्हाट टू डू.
यस बच्चों, अगर मुझे समझ में आ गई केमिस्ट्री तो आप सबको आ ही जाएगी. सो डू लाइक एंड सब्सक्राइब.
अब जो इतनी सारी ब्रेड छोड़ के है वो खत्म करते हैं.
चलो 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 आजा.
Yo people, enjoyed that video. So I'm sure you understand basically how to approach the problems of stoichiometry, and with a few more that we are going to do in today's class, I guarantee you will be an expert at stoichiometry by the time this class is done. Okay, so what we have to do in this case is identify the limiting reagent and find out the number of moles of the product that will be formed. Okay, so people, what is the first thing that we have to do? The first thing that we have to do is we have to write the ratio of the reactants. What is the ratio? The ratio is basically the initial amount in moles, yes, divided by the stoichiometric coefficient. That's what it is. So let's write the ratios over here. For A, what will be the ratio? The ratio will be 9 divided by 3. Yes, the ratio for A will be 9 divided by 3, which is equal to 3. 27 by 6 for B. Yes, which is equal to 4 point something something. We don't need to worry what exact number it is because we know that 3 is less than 4 point something something. Since we know this, we understand that A is my limiting reagent. LR stands for limiting reagent. Coolio. We know that A is the limiting reagent. Now the next thing that we have to do is we have to write the perfect scenario. And in the perfect scenario, we take the limiting reagent as it is. Now, how much amount of B will be consumed in the perfect scenario? Let's say it is X. And once these two are combined with each other, let's say the amount of C produced in terms of number of moles is Y and D is Z. Okay? Now, my dear friends, as you would remember from the video that you just saw, that in the perfect scenario, ratios are equal to each other. Yes. In the perfect scenario, ratios are equal to each other. So what's the ratio? 9 by 3. It'll be equal to 27 by 6. No. 27 is not the perfect amount. X is the perfect amount. So we'll write X divided by 6. This will be equal to Y divided by 3. This will be equal to Z divided by 5. From here, I can calculate X, Y, Z. Yes, so from this part, X will come out to be, X is equal to 3 cut 6, 2, 2 into 9 is 18, X is equal to 18. So basically, my dear friends, it means that moles of B consumed is equal to 18. Yes, so how much B will be left? How much B is left? 27 minus 18, that is 9 moles of B is left. Yeah, 9 mole of B is the excess. B is the excess reagent, 9 moles of it is in excess. How many moles of C are produced? Y is equal to 3, basically 9. Yeah, Y is 9. From here, yeah, from this part, you can figure out that Y is equal to 9. And similarly, what is Z equal to? Chalo, I have written Z in a different manner this time. So what is Z equal to? 45 by 3. This is equal to 15. Done. So my dear friends, 9 moles of C are produced and 15 moles of D are produced. Perfect scenarios ratio helps us determine that. Let's move on to the next question, which is very similar to this one. Same thing that we have to do for these numbers. Can we do it very quickly now? Very quickly, can we do it? Let's not write the ratio over here initially. 20 by 2 is 10. 24 by 3 is 8. So B is the limiting reagent. So my dear friends, in the perfect scenario, we'll take B as it is, 24 moles. Let's say this is X amount of A is consumed, Y amount of C is produced, Z amount of D is produced. As we know, in the perfect scenario, the ratios are equal to each other. So I can write X by 2 is equal to 24 by 3, which is 8, is equal to Y by 4 is equal to Z by 1. Okay, right? This is 8. So from here, X is equal to 16. So basically over here, we have 4 excess moles of A, right? And Y is equal to 32 and Z is equal to 8. So 32 moles of C is produced and 8 moles of D is produced at the end. Done. Nothing complicated over here, I'm sure. बहुत ही simple सा है. चलो जी. Let's go to the next one. What's going on over here, people? For the fun of it, you want to write the ratio. 30 by 10, 3. 21 by 7, 3. This is already the perfect scenario. There is no limiting reagent, no excess reagent. This is already a perfect scenario, yes? So what is the perfect ratio? Perfect ratio is basically equal to 30 by 10, which is equal to 21 by 7. Let us say X moles of C are produced and Y moles of D are produced. Let's just say that. Fine. So I can write this is equal to X by 2. This is equal to Y by 6. फटाफट से calculate कर लेंगे. All of this is equal to 3. Yeah. So how much X is produced, people? X is equal to 6 and Y is equal to 18. 6 moles of C will be produced, 18 moles of D will be produced. Done. Stoichiometry is very simple. Okay? Chalo ji. Now let's come to this question. How many moles of CH4 are required to produce 22 grams of CO2 after combustion? Can we write the equation first? Let's write the chemical equation. So the equation will be burning of CH4. CH4 plus O2 gives me CO2 plus H2O. Right? This is what we have. Now, should we balance the equation? Obviously we should. Yeah? So what do I do to balance the equation? Carbons are already balanced. Yeah, let's balance hydrogen. Let's put a 2 over here. So 4 hydrogen, 4 hydrogen. Hydrogen is also balanced. How many oxygens do we have? 2 plus 2, that is 4. So this is a nice balanced equation. So first step is to balance the equation. Okay. Second step is how many moles of CH4 are required to produce 22 grams of CO2. People, do you realize that one CH4 will basically produce 1 mole of CO2? Isn't it obvious from here? 1 mole of CH4 will produce 1 mole of CO2. So if we can figure out what is the number of moles of CO2 produced, the same number of moles of CH4 will be used to produce the CO2. How many moles of CO2? Given weight, 22 grams divided by molecular weight of CO2, that is 44 grams per mole. So half a mole of CH4 is required. No rocket science. Very simple. Balance the equation, get the answer. There's another simpler way of doing this, which is via principle of atomic conservation. We'll do that 2 classes from now. Okay? 2 more classes, then we'll learn principle of atomic conservation as well. Let's do this one. Find out the mass of CaCO3 that must be decomposed to produce sufficient quantity of CO2 to convert 10.6 grams of Na2CO3 completely into NaHCO3. Assume that H2O is present for the conversion process. Over here, knowing the chemical equations will help. Again, if you know principle of atomic conservation, this becomes simple. You don't need to write any chemical equations. But if you want to write chemical equations, let's try to do it in that manner. What happens is that CaCO3, calcium carbonate, decomposes in the presence of heat to produce CaO and CO2. Do you see that this reaction is already balanced? Basically, it makes our life simpler because 1 mole of calcium carbonate will give rise to 1 mole of CO2. Very simple. Now the next reaction that has been given to us is Na2CO3 plus CO2 plus H2O. This carbon dioxide from here is used over here. Okay, let me write that in red pen so that it's easier for us to comprehend. ठीक है जी. So you take Na2CO3, you take the CO2 produced from here, you take some water, H2O is present for the conversion process, and this gives rise to NaHCO3. How do we balance this guy? How do we balance this equation? Let's balance the sodiums first. 2 times sodium. Okay, sodiums are balanced. Hydrogens, 2 hydrogens over here, 2 hydrogens over here. Hydrogens are balanced. 2 carbonates over here, 1 carbonate over here. Do you realize? CO2 plus O. This reaction is balanced essentially. Carbons are also balanced. 2 carbons, 2 carbons, 3 oxygens. Sorry. 1, 2, 3, 4, 5, 6 oxygens over here. 3 into 2, 6 oxygens over here. So this reaction is also balanced now. So we have 2 balanced equations. Now what is given to us is, basically we need to find out the quantity of CO2 needed to convert 10.6 grams of Na2CO3 into NaHCO3. My dear friends, what we need to focus on is once again the ratio. Do you realize over here 1 mole of Na2CO3 needs 1 mole of CO2 to completely turn into sodium bicarbonate. NaHCO3 is sodium bicarbonate. Fine. This is sodium carbonate. 1 mole of CO2 is required per mole of Na2CO3. So if I figure out how many moles of Na2CO3 I have, I know how much CO2 I need. If I know how much CO2 I need, I know how much CaCO3 I should start with. So for Na2CO3, how do I figure out the number of moles? The number of moles are equal to given weight divided by molecular weight. What's the given weight? 10.6 grams. Divide by molecular weight. People, what's the weight of sodium? Sodium's weight is equal to 23 grams per mole. Carbon is 12. Oxygen is 16. If you do the calculation, you'll realize the mass is 106 grams per mole. So this gives me how much? 1/10 of a mole is. That's what we are starting with. So for 1/10 of a mole of Na2CO3, we need 1/10 of carbon dioxide. 1/10 of a mole of carbon dioxide is produced from 1/10 of a mole of CaCO3. So ultimately, my dear friends, this is the answer. Okay, we need 1/10 moles of calcium carbonate. Fine. 1/10 of a mole of CaCO3 is required. Now, what do? I have to convert this into weight. Find out the mass of CaCO3 that must be used. How do I convert it into mass? Basically, weight of CaCO3 needed will be equal to number of moles of CaCO3 into molecular weight or molar weight of CaCO3. What's the molar weight of CaCO3? Karo calculate zara. CaCO3, what's the molar weight? Very simple. 100. Okay. Calcium carbonate, the weight is 100. बहुत ही simple है यार. Okay. Calcium is 40. Carbonate on the other hand is 60. हो गया. Fine. So this comes out to be 10 grams. Calcium's molecular weight is 40 grams per mole. So weight of calcium carbonate that we need to start with is 10 grams. Very simple. Chalo ji. Let's do another question. For the reaction 4 times iron plus 3 times O2 giving me 2 times Fe2O3, 4.8 grams of oxygen is used to burn 0.15 mole of iron. Okay. What mass of Fe2O3 will be produced? What mass of iron will be left over? And what mass of O2 will be left over at the end of the reaction? This is standard stoichiometry question. Standard. Okay. Let's write the reaction once again. 4 times iron plus 3 times oxygen gives me 2 times Fe2O3. Now, my dear friends, what we need to write down is the initial amounts present. And we have to write that in number of moles. Yes, we have to write initial number of moles. So let's do the calculation over here in a rough area. Okay. So for iron, okay, what are the initial moles? Initial moles are basically given weight. Acha, mole of iron is given directly. So that makes our life easy. 0.15 mole of iron is given. Nice. No need to calculate for iron. Only need to calculate for oxygen. Oxygen कितना दे रखा है? O2. Basically 4.8 gram of oxygen is given. Yes. So given weight divided by molar weight. Now what's the molar weight of O2? Not O. This is a mistake that some people might do. You have to take the weight of O2 over here. 32 grams per mole. This is how much? 0.15. Yeah, I'm a little slow at mathematics, so please bear with me. But we have 0.15 mole of O2. So the number of moles of both of them are given as same. Now, my dear friends, what will be the ratios of each of these? Ratio will be 0.15 by 4 and over here 0.15 by 3. This is smaller. Denominator is bigger, this is smaller. So my dear friends, our iron is the limiting reagent over here. Nice. So iron is the limiting reagent. So in the perfect scenario, this will be used. I don't know how much oxygen will be used. I don't know how much Fe2O3 will be produced, but let's just write that down, isn't it? In the perfect scenarios ratios, okay, in the perfect scenarios ratios I can write that 0.15 divided by 4 is equal to x by 3 is equal to y by 2. Just do this calculation. क्या अब क्या लिखा है यहाँ पे? What mass of iron will be left over? 0. What mass of iron will be left over? 0, because iron is totally consumed. What mass of oxygen will be left over? That is something that we can figure out from here. Isn't it? We can figure out from here. So basically, oxygen consumed is equal to 4.5 by 4. Yes. Oxygen consumed, that is x is equal to 4.5 by 4. So calculate the weight of this. That is 4.5 by 4 into 32. Plug the value over and see how much is remaining. So how much of O2 remains? This is something that you have to calculate. This is your job now. This is the O2 consumed in moles. Convert this into weight. That is the O2 consumed in weight. Okay. Subtract that from 4.8. That's your job now. Let's do the analysis for Fe2O3. So from here, can I say that Y is equal to 0.15 by 2. This is the number of moles of Fe2O3 that are produced. So how do I calculate the weight of Fe2O3 produced? Given moles into the molar weight of Fe2O3. What is this? Iron is 56, oxygen is 16. Molecular weight of Fe2O3 is equal to 160 grams. Fine. So now you have to just multiply 0.15 into 80. Yeah. So at the end of the day, 12 grams of Fe2O3 is going to be produced. ठीक है जी? Done. Very simple question. Now this particular question, my dear friends, is a very interesting question, step by step question, and this is going to be your homework. Answer of this you have to give me in the comment section. Next class mein, or maybe in the next question of the day, that is going to be on Monday, I will show you how to solve this. Okay, so Monday morning in the question of the day, I'll solve this for you. Fine, works. So this is your homework question, you have to answer in the comments. So essentially what's happening is that KClO4 is being produced by so many reactions, starting with Cl2. ठीक है? Starting with Cl2. So you basically have to figure out a ratio between KClO4 and Cl2. Okay? That's the point that you have to focus on. You have to figure out a ratio between these two. So this is your homework. I will solve it for you in the question of the day on Monday at 6 a.m. So my dear friends, stoichiometry is done. The more you practice, the better you will get at it. There's no two ways about it, right? Practice questions you can find in the NCERT. I'll try to compile a PDF for you as soon as I can. My team is working on it. Since it's a new channel, I mean, we've started the channel again from a fresh start. So it'll take a little bit of time to get all of that work done because we don't still have a dedicated team to this channel. People working for other channels are also helping contribute over here. So as soon as I have a PDF ready, I will share it with you guys on the Telegram group. What is the Telegram group? t.me/v_VAP Vedantu Founders Channel. Okay, link in the description box once again. Cool. So people, if you enjoyed the fun that we did in the beginning, Pulkit sir and I am sure you understood stoichiometry with that. So if you enjoyed the entire class, the questions, make sure you hit the thumbs up button. Stay subscribed to the channel. Hit that bell notification icon. Comment with the answer of the homework question. And yeah, I'm going to see you in the next class of mole concept, which will be on solutions and their measurements. Cool. See you in the next one. Take care.